Okay, it's my pleasure to introduce our speakers for the December ECSS Symposium. Galaxy, as I'm sure most of you on the call know, is an extremely popular framework for running bioinformatics code and really doing much more. It's been interesting for me to see that we've got some science gateways in the Exceed program using Galaxy that have nothing whatsoever to do with bioinformatics. And so it's a really flexible framework, very, very popular. The public instance at Penn State, I think now recently moved to TAC, is heavily oversubscribed. There have been a number of efforts at looking to bring high-performance computing resources to meet this demand and to make things a bit more efficient, improve throughput, and what types of data resources the researchers have access to. And it's thrilling to me that by adding our high-performance computing resources in kind of an unobtrusive way behind a very popular framework like Galaxy, we can benefit so many in the research community, building on the very good work of the Galaxy developers. So I'm pleased today. We have a number of different efforts represented on the call, starting off with Nate Carr from the Galaxy team, who's going to talk to us a little bit about the project itself, and then moving on to several different speakers, both from the Exceed program and outside Exceed, who have done work porting to high-performance computing, improving data transfer techniques. And so you'll get to hear about a lot of different things. If you have questions, right now the lines seem to be fairly quiet, so I'll leave everything unmuted. So if you're typing or you have other things going on, please mute your own phone. If it gets too noisy, I'll mute everyone but the speakers. You can also use the chat feature to pose a question, and then I'll be monitoring that and can bring that up to the speakers as well. We have a rather large group and a large number of speakers. But feel free to pose questions throughout. If they're very detailed, we might hold them for the end or have you talk to the speaker offline. But please feel free to pose them and ask. So with that, Nate, I think you should be set to take it away.
Okay, thanks, Nancy. Yeah, so as Nancy mentioned, I work for the Galaxy project at Penn State. Primarily, I maintain the public Galaxy site, usegalaxy.org, and do development efforts related to systems and HPC tasks and whatnot for Galaxy. So I'm going to talk some about what our challenges were in the past, where we're at now, and what we're hoping to do in the next year or two. So just sort of an overview for people who aren't really familiar with what it is. We created Galaxy to be a framework really to make it possible for scientists to use tools that are not normally accessible to them. So especially in the bioinformatics world, and I'm pretty sure this is true across most scientific domains, tools that get developed to solve answer specific scientific questions tend to be command line tools that are kind of inscrutable and take all number of different specialty file formats and whatnot. And we really wanted to make it possible for anyone to be able to use those tools without any command line experience. So we created the Galaxy Web Framework, which sort of hides all this from the user. And as a benefit, each invocation of a tool, every time that you run a tool, you have a history that gets built up over time of what the tool's inputs were, what the parameters were that you provided to that tool, and then what tools the outputs were used in. So it sort of builds up this log of analysis that allows people to go back and actually see exactly what was done. So one of the things that we've really been pushing into as a byproduct of use of Galaxy is the way that Galaxy enables reproducibility. So, over time, we've added a whole bunch of other things. Workflows, I think, is on the next slide here. I'll get to it in a couple more slides. But we've added workflows, we've added visualizations and visual analytics. So Galaxy is multiple things. It is free open source software that you can download, run yourself on your own systems, on your own clusters, storage, whatever, and keep everything as private as you need it to be in that environment. You can also, we provide AMIs for Amazon EC2, where you can just start up and run a pre-configured Galaxy service, and we've got Grid Engine running there, and your own resources in EC2 that you pay for. But then since the beginning of the project, it's also been this service that we run for free at usegalaxy.org. We have all this pre-configured genomic reference data. We're now up to about 0.8 petabytes of user data. This is all data that's created by users, uploaded, and then as the output of tools. And we're running over 4,000 jobs a day, and actually that figure is getting better now that we've moved our operations to TAC. So just sort of a brief history of where Galaxy has come from. It started out sort of as some Perl scripts, as Gala, and in mid-2005 we really rewrote this as a pluggable framework, and really wanted to make it as easy as possible to plug tools into it. And then over time, we've just been adding more and more features. So now in 2008, we got workflows. 2009, we had data libraries and a lot of publishing features, which we call pages. In 2010 is when things really took off because we added a lot of tools for doing analysis of next generation sequencing data and a lot of data sharing features, which really made collaboration a lot easier in Galaxy. And then in 2011, we added the visualization, visual analytics features. And then finally, in 2012, we added the Galaxy Toolshed, which I'm going to talk about towards the end here. So over time, of course, this has really grown. These are the new users we've had registered per month on the usegalaxy.org public server. So, of course, it was pretty low and then really picked up, but then unfortunately sort of plateaued in 2013, and this was ultimately because we became sort of resource constrained. And there were a lot of reasons for this. This is a graph showing the amount of new data that was added to Galaxy every month. So we hit a peak here at almost over 100 terabytes in 1 month, and that coincided with when I added a whole bunch of new cores for analyzing NGS data. The problem was, of course, this was unmaintainable or unsustainable with the resources that we had at Penn State, so we had to add some quotas, and that's really sort of limited the usefulness of the usegalaxy.org service over time. And it really sort of came to a head over late last year, early this year, when you can see the number of jobs that were completed should have continued to go up and up, but eventually it started going down, and over this same period, the percentage of those jobs that were deleted before they were ever able to run to completion was going up. So this was essentially you submit jobs, they sit in the queue, they don't run, you get really frustrated, cancel them, and go away and never use Galaxy again. So that was a real problem for us. And luckily, over the past couple of years, we've had a number of people who have helped to solve this problem for us. So Exceed resources were made available to us through iPlant, and especially TAC and PSC have really been major contributors here, and then the ECSS project that we've been working on. TAC provided a number of dedicated resources for us to move usegalaxy.org to, and PSC gave us space on the data supercell there to mirror all of our user data. And so where we'd like to go now that we have this much more sustainable model, this is a shot of Blacklight at PSC, which solves a pretty unique problem in our field, which is genome assembly requires huge amounts of memory, not necessarily huge amounts of compute, but that's exactly what we think that Blacklight can solve for us. And so we have been doing some preliminary work, and we've been running a few jobs on Blacklight from Galaxy at Penn State. Now we want to get that working with usegalaxy.org public site in production. And in addition, the small amount of dedicated resources that we have at TAC are fantastic, but we're already, resource bound down there as well, and we want to be able to expand onto all of these Exceed resources that we have available to us through our own allocations, iPlant, and whatnot. And so that's where a lot of the upcoming work is going to go in, just to be able to run on things like Exceed. So we're going to continue work on our ECSS project to try and get to the point where we can submit jobs to anywhere that we have Exceed resources available to us. We want to make a Globus online endpoint for usegalaxy.org to make it much easier for people to get data into Galaxy and also out of Galaxy, which turns out is a real challenge. And one of the biggest components of this is instead of just getting allocations for Galaxy itself and using these allocations, we'd like people who have their own allocations to actually be able to allow the usegalaxy.org service to run their jobs on their allocations, which really adds a huge scaling component to what is available to people. And just some additional features for reporting back to users where they stand in the queue. To really be able to take off on performing massive scale analysis, there is going to be some work done in the next year to improve the way that we do our workflows. Right now, we have a great workflow system where you can say, I have a data set and I want to run these 100 tools in specific order with certain parameters on it, and I want to do that every time I get a new data set. And that works pretty well, but if you have hundreds of data sets to analyze all at once, that system, our workflow system, is not well suited for that. And so we want to solve this from a UI perspective because we don't have a great way to track workflow inputs and outputs, and just improving the performance of the back-end scheduling engine for workflows. We have a lot of tools and workflows that are being built out there by the community, and we on the Galaxy team don't really have the manpower and the effort to put all of these tools and workflows into Galaxy. And so we're trying to move that onto the community as much as possible, to make it as easy as possible for people to develop workflows and define the best practices and integrate and share their tools that they develop outside of Galaxy and make those all available within Galaxy. And then another problem that we're looking to solve is to make it as easy as possible for people who have data in usegalaxy.org or maybe in their EC2 or local instances of Galaxy to make that data available to other Galaxy instances. Everything right now is self-contained inside a specific instance.
Nate, we have a quick question on workflows before you move off, if you don't mind.
Mm-hmm.
Does improved workflows mean making metadata on data sets available as variables to workflows?
That may be necessary, and maybe I'd want to understand a little bit more about what the real great use case is for that. But
Curtis, do you want to ask just briefly? I don't want to diverge too much, but we might be able to answer this quick.
So this is Curtis Hendrickson at UAB who asked the question. Even on the current Galaxies, running on a few tens of samples using workflows can be daunting because the outputs don't get labeled by sample ID, and there's no real way to hand that across easily from the data ingest. And sort of sample tracking is a big nightmare when you're running large arrays of data sets. So if you're shooting for large-scale data sets, how do we handle tracking samples and metadata of that nature?
I see. So you're talking about not necessarily file format, specific to that data type, but something that can be passed along through the entire workflow to say this is all associated.
Yep.
Yeah, right. So that's exactly what we're trying to solve. We're looking at it from the UI perspective. I could certainly see that a metadata component would be part of that as well. But we were, I think, the most recent proposal is to sort of have workflows that appear as items in the history. And so everything, all of the data sets that make up that workflow sort of have a container around them, so you can see exactly where they came from.
What's the best way to participate in how that gets formulated? Because that's an issue we run into a lot, actually.
Yeah, so I think we were trying to talk about this a bit internally, and then we were going to solicit some feedback from the community. So there will probably be a post out to Galaxy Dev, which you're on, right? So
yes.
Yeah, we'll be definitely involving community.
So we go to Galaxy Dev and not Galaxy Announce. Okay.
Yes, I believe so.
Thank you.
Okay. So for this first piece of having all these tools out there, we've developed the Toolshed, which is essentially a community site for people to be able to upload their Galaxy tools that they've developed and the definitions of how to include those within Galaxy, and then make it possible for Galaxy to automatically install these kind of like a package management system. So if you're running your own copy of Galaxy, you can install tools directly from the Toolshed, and also people who are developing tools that we want to be part of the usegalaxy.org site, they don't have to wait for us to include them and have this difficult process of submitting patches. You just maintain it on the Galaxy Toolshed, and we can pull those directly into usegalaxy.org and really get visibility for a lot of these tools. And then for the second component, which I think Phil's going to talk about in more detail, we're looking at creating a data exchange service so that different Galaxy instances can share data directly between them. So we need a federation layer where we can uniquely identify users across different instances. And then since we already have all of usegalaxy.org's data mirrored in the supercell at PSC, the /2 file system that they've developed there might be a component of how we move this data around. But that work's still in progress. And we are growing and continue to grow. We've been doing a conference just for Galaxy for a few years now, and the next one will be in June, late June of next year. That's the information for it.
Nate, thank you very much. I see no further questions, and in the interest of the rest of the speakers, I think I'll move on, but that was very nice laying the framework for really the rest of the following talks. So thank you very much, and thank you for spending your time with us today. Our next speaker will be Phil Blood from the Pittsburgh Supercomputing Center. Phil actually organized this whole series of Galaxy talks today, so I want to thank him for that. And Phil, I think you should be able to drive the slides.
Great, thanks Nancy, and thanks Nate for coming. So I'm going to talk about some of the things that Nate touched on, and our efforts to, in ECSS, we've had a project to establish an Exceed gateway at Galaxy main, the main Galaxy instance, so that, as Nate said, folks can submit jobs to Galaxy main, and they'll actually run on the back end on Exceed. But before I get too far into it, there's a bunch of folks that have been working on this over the past actually couple of years, off and on, with different disruptions at different times. Right now, actually, James Taylor and Anton, they're the two PIs of the project, and James is in the middle of moving his lab to Johns Hopkins from Emory, so he couldn't be with us today. But Nate, who you just heard from, sort of makes everything run there, so we're grateful for him stepping in. And then these are just the folks who have contributed to the work I'm going to talk about on the PSC side. Folks, Alex Robolewski, who did a lot with the Trinity, getting the applications into Galaxy that we needed, and also Josephine Palencia on that end, integrating with some remote submission stuff, and then Jared Yanovich, Bob Budden, and Shui, who worked on the file system and data migration stuff, and Sergio, who's helped sort of tie it all together. So quick acknowledgments there. This is just, I stole this slide from, I think, from Anton, just showing that genomics is stepping into the realm of the big boys in terms of data production, matching some of the physics and astronomy efforts, although in a distributed way. This is the total theoretical output of the Illumina HiSeq sequencers out there in the world. I think this is dated. It's probably out of date now. But data production is growing exponentially, and can Galaxy be used to handle these big data? Right now, Nate talked about some things they're going to do with the UI to help to facilitate that, but also we have this issue where no one, certainly the Galaxy main instance, as Nate indicated, doesn't have the resources to handle all this, and so what people have done is install their own Galaxy instances on their campuses. We actually have one on an Exceed resource at Indiana, which you'll hear about later on. You'll also hear from Globus Genomics, who has used their own Galaxy instance to allow people to submit genome analysis tasks to their sites. We hear about that. It's also available, as Nate said, on Amazon. But all these things are there's a division, right? It's compartmentalized. You have to go to one or another site, and it inhibits the sharing of these different data that are being generated and analysis of these data. And so I stole that graphic from Nate, and I should have edited it a little bit. So this is the graphic he used to demonstrate the tool shed. But what eventually we'd like to do is, as Nate alluded, is actually create a data exchange where all of the data in Galaxy, I've got a pointer, there we go, all the data in Galaxy can be shared, so the analysis, the workflows, and all these different instances on public and private clouds and private Galaxy installations on campuses could have a mechanism to share and exchange data, analyses, workflows, and the whole bit. So I've called this, in honor of Star Trek fans, the United Federation of Galaxies. And so let's see if I can still advance the slides with my pointer. All right. So one step towards that, as I start out talking about, is establishing this Exceed gateway on the main Galaxy instance, which is now hosted at TAC. Because a lot of the technology we need to develop to enable this big federation of Galaxy instances it can be developed in this effort to enable remote job submissions across different back-end sites on Exceed. And Nate's already talked about this. We especially want to offload things like de novo genome assembly, which require huge amounts of shared memory, and other very intensive tasks, and do this in a way that's transparent to people actually at the Use Galaxy site. To do that, we need to solve a couple of basic problems, just getting the data where it needs to be. Galaxy was developed originally with this idea of it being a local installation and with one file system. And so we need to figure out how to get the data where it needs to be on these remote sites in an efficient way, and then actually managing the job submission. And there's other issues to solve, authentication and so forth, which you'll hear about a little bit more later. And so this is just a quick, very concise summary of what we've done so far on the PSC side. And this was before the Galaxy main site was migrated to TAC. And so we'll have to revisit some of these things a little bit, but we can reuse much of the work that we've done already. So we established a network link, made Penn State connected to ExceedNet, basically, with a 10 gigabit link, and then moved all the Galaxy data to PSC. And then we established a common wide area file system between PSC and Penn State using the /2 file system, which we've developed at PSC, which has been developed as the ground up to be a wide area friendly distributed file system. It's mounted via Fuse and is really built and designed for federating different data resources. It runs on top of ZFS, and it can integrate with a number of any other basically POSIX file system. And there's more information at this link here if you want to find out more, and I have a couple of slides at the end more about that, which we won't have time to go into today. but that's sort of a glue that we're looking at for tying some of these things together. And so we actually were able to establish that, and then we were able to implement some remote job submission capability into Galaxy just via simple SSH mechanism, getting the tools into Galaxy at PSC that we needed, that they wanted to use on Blacklight, Velvet, and Trinity, being two good examples of common codes people would like to run. And then we're able to submit jobs from Penn State using this common distributed file system, and have them run on Blacklight. So this is just a quick picture of what this looks like. We have PSC and the Galaxy main site being linked together, which is able to replicate and migrate only the data that's needed. There's a lot of facility and hooks within the file system for doing this that Galaxy can take advantage of. And wherever we actually do the computation, we'll have a local copy of the data there for performance. So running through this quickly, so we have make sure we have time for everyone. But please, stop me, or if you have a quick question or something's not clear. I've been thinking about this for a long time, so I may make assumptions that make me skip important details. So stop me if you need to ask a question. So this is a list of some of the things that are high on our priority list to do next, and not necessarily a comprehensive list. There's some details in here that have been left out. But as we mentioned, just taking this proof of concept that we've done and finding a way to integrate that and test it with the main Galaxy site and get that up and running. I mean, that's the overall goal. But then within that, there's some things we want to do to improve what's being done, what we've already tested and done with this initial proof of concept. And that is, right now you have to hardwire these job submission scripts with the amount of resources you're going to use on a particular resource and that sort of thing. Within Galaxy, these job runners, they're called in Galaxy. And the new Galaxy software has facility for dynamic job submission where these resources can be designated at runtime based on the requirements of the job. And so we want to get that working with the remote job submission protocol that we've developed. And then there's a lot of testing to be done on ways that Galaxy can manage and move data around to efficiently, intelligently migrate data, replicate it as needed, and then use it on distributed compute resources. So we'll be testing various things with /2 and other technologies, some of which you might hear later on, to do this sort of thing. And we're in a good position, though, with our /2 file system development because we were just awarded NSF DIBS award to further develop /2 to do this kind of thing, to tie things together, to facilitate these types of data analysis and shared analysis that everyone's talking about. So, we'll have the opportunity to test and actually target, what some of the requirements of Galaxy and Galaxy users in our development of /2. And then we have to deal with authentication, both in submitting jobs to Exceed and also once we developed a distributed file system, a shared file system, authentication and access to that was also something that needs to be dealt with, and also looking at some of these other technologies that are out there that other people have expertise in. TAC, there's a lot of expertise with iRods, and then we'll hear more about Globus Genomics in a moment. So that eventually we hope we can move towards through this initial Galaxy Exceed gateway. We'll be able to develop some technology that will enable us to join more Galaxy instances into this federation that can submit jobs, say, to Exceed resources or any remote resource, and have the data visible to all these different Galaxy instances. So with that, I will stop. And as I said, there's a couple of slides at the end here that give some detail, and hand off to Indiana and Rich Leduc.
Hi, this is Rich Leduc. So I just want to take a few minutes before we get into the technical part of our talk to familiarize you with the National Center for Genome Analysis Support and what we do with the Galaxy. So NC-GAS is an NSF-funded initiative to help biologists get access to large memory clusters, or to help NSF-funded genomicists get access to these clusters. And one of the things we did early on was, let's see if I can, there we go. One of the things we did early on was to use Galaxy as a portal to help our users use our cluster without needing to resort to the command line. And so our structure is pretty straightforward. We have a VM running our instance of Galaxy. It can see two of our clusters. Both of these clusters mount our Lustre file system, and works pretty well right out of the box. We have done a little bit of work, which we'll talk to in a minute. But had I been the kind of guy that would read all the instructions carefully, I would know that my animations were going to get munged here. So this slide is a brilliant slide, just trust me. But what we're getting at, what we want to do, is to allow data to move directly allow our users' data to move directly from where it's being generated onto our systems, allow them to go through a Galaxy portal and submit their jobs. And this sounds exactly like what Phil was just saying. So we have a much smaller problem. This is our core hours over the last year, I think. And as you can see, we're running a real small shop, but we're doing a lot of this stuff already. And with that, I'm going to try and pass control over to, do you have it? Oh, okay. Just say when. Yeah. So, to talk about the effort we have on CI login authentication. You can just say.
I need to share that. Hi, this is Yuma. I'll be talking about the authentication piece we did for the NC-GAS Galaxy. So I'll be doing a small demo afterwards. Okay. So can I get a control?
I don't know.
Probably I need to be.
Yeah. Do you want me to transfer control to you?
Yes, please. I would do a small demo after the slides.
Okay. Very good. Okay, I think I'm also going to mute the rest of the lines at this point, too.
Presentation mode is now enabled.
Can you say something?
Yes, hello?
Great, yep, I can still hear you. Thank you.
Okay, great. So for the NC-GAS Galaxy, we have some authentication requirements so that we can enable ECSS users to use our resource. First of all, we want external IU users to authenticate with NC-GAS Galaxy using their in-common credentials, and we only want NC-GAS authorized users to authenticate and use our resource. CI logon service provides a mechanism to do this, and it also supports MyProxy OAuth protocol for certificate delegation, so that it can enable our gateway to access the cyber instructor in the back on the user's behalf. So we decided to take the approach of incorporating CI logon as an external user authentication for Galaxy, in addition adding a little bit of homebrew authorization mechanism. This presents some technical challenges for the implementation. First of all, the existing CI logon OAuth client implementation is done in Java, and while Galaxy code is in Python. And in the meanwhile, Python also lacks the full-featured OAuth libraries to support the signature method required by the CI logon OAuth interface. Also, once a user is authenticated through CI logon, we need to forward the remote username to the backend Galaxy through the Apache proxy. This is just a standard configuration in the Galaxy remote user authentication configuration. And also we need CA logon handles authentication, but we also need additional authorizations for the authenticated users. And also some of the default CA logon ID providers, it includes like open ID providers which are not desired for the NCGS Galaxy users. So here's the architecture for our final solution. We end up implementing a CA logon OAuth client in PHP that's sitting under the Apache web server, which acts as a front-end proxy to Galaxy. And when the user comes in, it goes through the PHP CA logon OAuth client, and it gets redirected to CA logon. The user can authenticate through their home institutions, then redirect it back to the NCGS page, where our PHP CA logon client has from the authentication we get the remote username, and we forward that to the backend at Galaxy through the HTTP cookie rewrite. So our list of so to recap, our list of technical highlights here include PHP implementation for the CA logon OAuth client, which is very lightweight. And then we need to configure the Apache to act as a proxy to the Galaxy. The first two configuration steps are pretty standard. It's listed in the Galaxy administrative guide. So the only thing we need to add is to configure the Apache for CA logon authentication using HTTP cookie rewrite. It's also just a few lines of rewrite rules in the HTTP configuration. Finally, we contacted the CA logon developing team, ask them to help us customize the NCGS scheme so that it limits the ID. When user logs in, the list of IDPs are limited only to in-common academic organizations. We also implement a very simple, lightweight PHP-based single file-based user authorization so that only authorized NCGS users can log in. And this whole implementation is very lightweight, and we package it for general. If you have a general Galaxy installation, you can use that, and it's open source, and you can find more details at a link listed on the page. So now I'll just do a quick demo here to show how it works here. I guess I'm going to share my desktop. See if that works. Is my desktop share? I click on sharing.
Yeah, that should be the right thing to do. I don't see it quite yet.
Okay, it's just slow.
But yeah, the work that you're describing is really relevant, I think, also to what Nate was talking about at the beginning, where you have Exceed users ask for their own allocations and then access those directly. I think this would be quite related.
Right, and one of the questions I have while the demo's coming up, and that I'd like to come out of this discussion that we had, this is Phil, is what we can do to help together the different efforts that are sort of complementary that have been going on. I don't know, sort of independently, maybe with some back and forth discussion. I think that's a hot topic for Nate and James and Anton, the Galaxy development team, is how to bring together these things back into the main Galaxy code.
Yeah, very good. While we're waiting, we also had a question for you, Phil, from Curtis Hendrickson, who asked, did the existing Galaxy wrappers for Velvet have to be rewritten to be Exceed compatible? And I can maybe unmute if Curtis wants to state that directly himself.
Nancy, could you transfer I'm having problem running sharing my desktop. Could you transfer it to Rich? Yeah, transfer Rich.
Oh, transfer to Rich? Yeah, sure.
Really easy. We can share. We can do it on his desktop.
I am doing it.
I think so. I did not do that directly. So that was Alex Rupileski and at PSE who put the job runners for Trinity and Velvet into our PSE instance. certainly the job runner on the back end, I think, had to be modified for to run on blacklight. Maybe, and Nate might be able to actually answer this question better than I can.
Yeah, so right,
Presentation mode is now disabled.
They're not running the jobs directly through. They're essentially submitting jobs because it's local to DXC. So there's nothing specific to Exceed going on with that.
Right, that's right. Yeah. So it was just putting it in and making sure it could run. It worked nicely with PSC's queuing system. Was that something separate to the wrapper that?
I don't recall. There were actually a couple of versions of the Velvet wrapper, I think, and or maybe a couple of versions of the Trinity wrapper, and I'm not sure which one they used. Alex would know that for sure.
Yep. So we can follow up offline if you have further questions on that.
Okay, thanks guys. I transferred control to Rich. It doesn't seem that the shared desktop is working yet.
Yeah, it's not working for us either.
Nancy, if you have time like this, Suresh, you can transfer to me and we can give it a try. If not, you can move on.
Okay. Yeah, so we have about 15 minutes. Let me I'll give you guys 6 seconds. Okay, you should have control, Suresh. Oh, there we go. You got it. Okay, I'm going to just mute the background. Oh, no, but you're not in as a presenter. Okay, I'll just leave the audio as it is.
Terrible idea. If I worked with Woo, you don't think it's very good.
Yeah, so it's just for the demonstration, if you just go to the galaxies.ncgas.org webpage here, and then it's going to redirect you to the CL logon authentication page. Here's a customized NCGAS theme that has only in common academic institutions. And default Indiana University, I choose login, and when I log in as me, it's so I'm an authorized user, and it should redirect me back to it. Just gets me logging directly into the NCGAS Galaxy page. So do you have a separate browser? I need a different browser. Okay. Yeah. So if you have if you are an unauthorized user, for example, trying to log in, Galaxy. Then if an unauthorized user trying to log in, I think you will be redirected to the Galaxy help page, NCGAS help page, asking you to. Oh, so you are authorized user. Okay, so then you will be directed to NCGAS help page. It should be directed here. I think the main point is that this authentication helps you so if users can just use their home institution credentials to access our resource once they are authorized, and that's all. We can move on to the next presenter.
Thanks very much, you.
Uh-huh.
Okay, Roger, I will transfer this here.
Go ahead.
Oh, could you stop sharing the desktop? I think I can't grab control. Yeah, there we go.
What? You're not going to
Yeah.
Okay. You're going to pick up, considering that when you turn it on, you're going to get that.
Okay, so since we have 10 minutes, I'll try to be very quick and Just want to thank you, Nancy and Phil, for inviting me to give a talk to present about Globus Genomics. So Globus Genomics is, I know, Nancy, I don't know if you wanted to introduce or, because we're running out of time, so I just wanted to.
Yeah, go ahead, please.
All right. So thank you for inviting us, and I wanted to. So Globus Genomics is a service we created and we operate. The goal is to create a sustainable service for genomics analysis using Amazon and Galaxy and Globus technologies. So I was asked to talk more about technology details of how we went about creating Globus Genomics and run it and operate it. So I'll try to stress on that as much as I can while I go through the slides. So this is the technology architecture. It's not very fancy. We use a sort of a shared file system, Condor, HT Condor, to do the job submission to create a dynamic cluster. So the goal is that data from various sequencing centers, Broad and Illumina, and wherever users are getting sequencing done, would flow to Globus Genomics, to a Globus endpoint on Amazon, directly using the Globus transfer. And users can take advantage of some existing pipelines that we created on Galaxy. Essentially, when the user runs the analysis or starts the workflows, a dynamic cluster gets created using HT Condor with a shared file system between the compute nodes. And we have an elastic provisioner that goes and creates a virtual cluster with a combination of reserved, on-demand, and spot instances, and runs the analysis at scale. So this is sort of the overall high-level architecture of how Globus Genomics works. We do some interesting things that, from a technology perspective, that might be of use for people who are on the call. So what it does is we've integrated the identity and group management in Galaxy with Globus. So a user can log into Globus Genomics using their Globus ID, and so in the back end, what's happening is that we are using the Globus API to do a OAuth dance. So when the user presents his Globus, logs in using his Globus online username and password, it gets redirected to the Globus website, and the user will get a chance to say whether. So the Globus website will ask whether whether the user's credentials can be used to access Globus Genomics, and then when the user clicks yes, then that gets redirected back to the Globus Genomics account. The interesting thing that happens in the back end is that if the user, a Unix account gets created on the Amazon instance for the user with the credentials in the right place, we use the My Proxy server to generate a credential for the user, and that's how when the Globus transfer is used from within the Globus Genomics Galaxy, that's how the user gets authenticated to a Globus endpoint. In addition to just the data transfer capability, we also have the group management capability integrated. So we can create groups of users in Globus and control authorization to Globus Genomics instances by using the membership of a particular group. And from the computational aspect, we did a fair amount of analysis or creating profiles for various analysis tools, so that we can pick the right combination of Amazon compute to run a particular tool at scale. For example, BWA alignment in general requires a lot of compute and I/O, so we typically run it on a dedicated node with 32 virtual cores and 256 gig RAM, which is the highest you can get from Amazon. But recently they released a better new instance types that is showing a lot of promise for the alignment. For a regular exome, we've been able to align it in less than 2 hours, which is quite nice. When we started doing Globus Genomics, the alignment process took close to 8 hours to finish. Now it's less than 2 hours. So as more and more instance types on Amazon get introduced, the time to do the analysis goes down. So the resources are sort of provisioned on demand for user. So because it's a pay-as-you-go service, so we don't keep a compute cluster waiting for the users to run. So it gets assembled at runtime. And right now we use clusterfs as a shared file system, but we're thinking of moving towards Lustre for performance and other reasons. There's better support for Lustre. And we do provision I/O for the shared file system. So in order to get better bang for the buck or better performance for the analysis pipelines, we provision the I/O on Amazon. So it costs us a little bit more, but it is very, very well worth it. So in the last 6 months, we've gotten a pretty good usage. This graph just shows the usage for the month of October. We have over 20 groups of researchers from various universities pounding on the service quite heavily. The last 6 months, we've burned over 350,000 core hours in Amazon Compute, and we've been doing more and more interesting analysis. So the goal is to create sort of an ecosystem of very well documented and pipelines that just work, that users can just take advantage of and build on top of those pipelines and kind of make it an interesting, make it useful for other researchers also. So some of the samples, so I just wanted to kind of quickly give, so we work very closely with Nancy Cox Group at University of Chicago, who created this really powerful consensus calling pipeline that uses 4 genotyping algorithms and calls consensus on various VCF files to purify the data. And it's gotten a lot of interesting traction. We're working on a journal paper right now, and we're trying to reuse this pipeline across multiple other users. And the goal is to publish this pipeline for general use. We had discussions with the Galaxy group in making this pipeline available for everybody to just generally use it, so that people don't have to recreate it. So that's been going on. So as mentioned, our goal is to create a sustainable service for genomics analysis, and one of the key aspects for sustainability is to make sure that we have identified the price points and what it costs for the researchers. So this is our pricing sheet, and I don't want to spend too much time on it, but it's going down quite rapidly. The price of doing an exome analysis or a whole genome on the RNA-seq on Globus Genomics is that. So this work, it's largely by an NHLBI grant from the cardiovascular grade and the DOE grant. So wanted to thank everybody for giving us this support. And for more information, you can go here, read about it, and if you're interested to sign up or ask more questions, let me know. My email address is in the beginning of the presentation. I think it's madhuri@anl.gov. I don't know how much time we'll have for questions here, but if you have questions, feel free to send me email. I'll be happy to answer that. Thank you.
Ravi, thank you very much for a great presentation. On the symposium website, all the speakers are listed and also links to URLs that provide their contact information. And the slides will be up there as well, and the recording. So if you think of questions later, it'll be easy to find your presenter and ask a question. Suresh Maru had a great comment during Ravi's talk, and he said all the talks have nicely presented complementary capabilities. Can we plan a day-long virtual hackathon and brainstorm about all the Exceed contributed features and integrate them into the main code base? So this is probably an idea to bat around with Phil, with Nate. It seems to make a lot of sense. There are so many things going on. I think so many people are excited about Galaxy and its capabilities that there's been a lot of activity and a lot of complementary activity, which is really nice.
me on the website. I've tried.
I wonder what you think of that idea, Phil, Nate.
Okay.
Yeah, I'll defer to Nate on that as they're driving the development. But that hits right on the head of sort of what I was thinking about as I was putting all these presentations together in one slide deck here. Is how, they are complementary and what can we do to help integrate that? So getting together in some form sounds great to me.
Yeah, I agree. We'd like to get a lot of things back into Galaxy. So. And I know there's a lot of overlapping effort out there. So.
Yeah.
I mean, this might be, this is Sergio, this might be kind of a more, I mean, your conference is end of June, right, 2014, so hopefully we can get a lot going before then, but maybe one point on the timeline would be some kind of an event or meeting or whatever it would end up being at your Galaxy conference.
Yes, definitely. We've got all kinds of breakout sessions and whatnot going on. So
I mean, I guess it would depend on what shape the collaboration congeals into by then, but it could even be like a workshop, or because I think it might take a few sessions before we actually get down to a hackathon. There might be some kind of higher level design things first, and then see what actual where some actual common coding exercises would be in order and things like that. So
the other thing is that we're going to be working on the next iteration of the ECSS project to support our the development of this gateway and see what that takes. And so the other thing would be to maybe those on this call to talk about and see what part each of the groups represented here should play in the development of that ECSS project.
Yep.
I mean, I'm excited.
Yeah, very great ideas and a great note to end on. I think between the Galaxy conference at the end of June, early July, and then the Exceed conference in mid-July, there might be some kind of tie-in in between the two also, which would be great.
I think that's on my to-do list is to reach out as we start to formulate that at the beginning of the year. Here we'll be formulating this next phase of the ECSS project. So I'll take that on me to follow up.
Okay, that sounds great, Phil. We have one more question. I'm probably going to go ahead and end the call because this one sounds like a great online question. But Tracy Teal asked about integrating Galaxy with their local HPCC resources and linking them to Galaxy Main and Exceed resources and suggestions for best approaches given these new developments. Would that be a decent question to send to you, Phil, first? I know you're not the gateway guy, but
yes, please send that to me. We're actually working with another group who has that very same question, and so we're getting started on trying some things. They're really complementary questions, and to developing this Exceed gateway versus a local HPC center or a campus HPC center also being able to offload jobs to Exceed, say. So yes, we're looking at that, and I'd love to talk about that with you further. So send me email blood@psc.edu.
Okay, great. Does that do it for you, Tracy? Oh, great. She says great, thanks. Okay, terrific. Thank you, everybody, for a terrific call. I'm going to go ahead and end the recording, and please join us in January for the next ECSS-symposium.
Thanks, Nancy.
Thanks, everyone, and especially our speakers for taking time to prepare and present today. Very, very informative.